Good morning. This is Akanksha Shukla from IT department. Today I am going to discuss one of the topic of data analytics, that is data streams. Basically, what do you mean by data streams, or what are the concept of streams? First of all, we will discuss about the data stream topic. So, the data stream is a stream or a data which is in the form of voluminous amount, or it is in the form of huge amount, which comes from various sources. Just we can't define that this particular data is coming from any particular source. So this data can arise from various different sources. So this is the continuous or ordered or voluminous amount of data, or you can also say that the chain of items, and for the users and for anyone it is unfeasible to control the order in which units or in which form this data is arriving. It is unfeasible to control over that particular kind of data, and also to capture that particular stream in the entire form is also not feasible for anyone. Okay, so in short we can say that it is an enormous volume of data which arrives at a very high rate. Okay, now there are basically different types of data streams. First one is data stream basically. So the data stream is possibly, you can say that it is an unchained sequence of items or tuples, where each and every tuple comprises of the set of attributes. Just like in the database table we see the rows. So here the tuple comprises of set of attributes, just like similar to the databases tables in which we uses the row in the database table. Here the data stream is a sequence of tuples where each tuple comprises of the set of attributes. The data stream has different sets of data which can depend on the chosen data formats. The first one is attributes. Okay, so each attribute of the data stream represents a certain type of data, just like the segment or the data points or their IDs or the timestamps or the geographical data. Okay, so attributes we can say that attributes is the additional properties or the additional characteristics which the data stream comprises of. The second one is timestamps. Timestamp attribute. Basically, this attribute helps to identify when any event occurred at a particular time. So the timestamp, when we are going to add the timestamp to the particular data streams, then that particular data stream, then other one can easily identify that at what time that particular event occurred with the help of timestamp attribute. Okay. The next one is subject ID. Basically, it is a encoded by algorithm ID. So it is an encoded by algorithm ID which has been extracted out of the cookies. Okay, so subject ID is basically helps in identifying the data streams which is extracted by the cookies or from the cookies. Next one is raw data and the processed data. So first of all, raw data, which includes the information straight from the data which is provided without being processed by any algorithm or nor by human also. Okay, so raw data is the original data which is extracted or which is derived straight from the data provider. Okay, it is directly provided from the data providers without being any processed or without being any processing, including any processing systems. Next one is processed data. Basically, this kind of data has been prepared. Somehow it is being modified or it is being validated or cleaned to be used for future purpose or to be used for the future requirement actions. Means if anyhow in the future some data is needed, so processed data is basically prepared to be used for future actions or to be used for fulfilling the future requirements. Now, the second type of data stream is transactional data stream. Basically, this kind of data stream is a log interconnection between the entities. Okay, here we can see that various the data stream which comes or which arrives during any transactional activities or during any transactions, that comes under the transactional data streams. Okay, just like credit card. So whatever the consumers are purchasing from the producer, these whole entries or these whole data can comprises the transactional data stream. Second one is telecommunications, means whatever the phone calls by the callers to the dial parties are occurring, or whatever the inquiries, whatever the calling process, whatever the information is sharing between the callers and the dial parties, these communications or the data of these communication during these communication process comprises all of the transactional data streams. The third one is web. So whatever the accesses by the clients of the information at different servers, these all information what are the clients are accessing over the servers, these information accesses by the clients at the servers included the transactional data streams. The third one is measurement data streams. Basically, in measurement data streams, the data which comes or which arrives during any measurement process comes under the measurement data stream. Just like sensor network means the data which is collected by the sensors or during or any type of phenomena, just like physical, natural phenomena, road traffic. So these activities when received or when observed by any sensors, so whatever the data it is collected by the sensors, it comes under the measurement data stream, because it is a qualitative data, it is a quantitative data which is measured by the sensor networks. So this comes under the measured data streams. Second one is IP network. Basically, whatever the traffics at the router interfaces are occurring, or whatever the information passing over that particular IP network, or somehow if anybody has committed fraud, or anybody has threatened the somehow network, just like the one of the cryptographical attack is denial of service attack. So if you want to identify that particular IP network of that particular system from where that particular attack is arriving or occurring, so to identify these kinds of frauds or to identify these types of networks, we can easily use that particular measurement data streams to identify the IP network of that particular system. The third one is earth climate. So temperature, humidity level, weather stations, these all information or these all queries through which we can identify the climates, or these kind of information just comes under the measurement data stream, because it is consisting of the data which is in the form of quantitative data. So that particular kind of data comes under the measurement data streams. Now, there are various stream sources. First one is sensors data. In a navigation system, we can see that sensor data is used where we cannot easily uses the cameras, where we can have the images in the terabytes or in the voluminous amount. So for that particular kind of data, for observing that particular kind of data, we can use the sensors data. Okay, so just like here in the example given, they imagine a temperature sensor floating about in the ocean. So sending back to the base stations a reading of that particular surface temperature per hour is required. So that particular data generated by this sensor is a stream of real numbers. So we have 3.5 terabytes arriving every day, and we for sure need to think about what we can in kept continuing and what can only be archived. Basically, what is the concept of data stream? Basically, in the data stream, we have voluminous amount of data, we have huge amount of data occurring from the different types of sources. So for us, it is a very complicated situation that which kind of data we have to store or which kind of data we have to only kept for archiving, because we can't be able, or it is not feasible to apply the queries over all the voluminous amount of data which is arriving from the different sources. So the most important aspect is that from that particular voluminous amount of data, we have to identify that which part is useful and which part is useful in our future actions and which part is not useful at current time. So this identification is very much important for the data streams. Okay. So here the same thing is explaining here, that suppose we have 3.5 terabytes data is arriving every day. So we have to think about that which what particular amount of data you have to kept continuing and what kind of data or what amount of data you have to kept in archival storage. In the next slides, I will explain about the data stream model and architecture. Here I can explain better this thing, that what is temporal storage and what is archival storage and what is summary all data storage. Next one is image data. Basically, satellites frequently, just in the given example, just like satellites frequently sending the down to earth streams, which also contains many terabytes of images per day. So here what we use the surveillance cameras that can generate images with the lower resolutions than the satellites. But there again the same thing happens, that there also a numerous or voluminous amount of data is arriving. So each producing a stream of images at a break of 1 second each. So again the same thing comes, that which kind of images is useful, what to keep in continuing or what to keep in archival storage. Next one is internet and web traffic. Here in the given example, here it is written that a bobbing node in the center of the internet receives the stream of IP packets from many inputs and paths, and then it produces the output. So for example, here the primary example is Google, about the Google. Basically what we do, we usually search over the Google any topic, but what we see, that the user or the server is unknown, that when and which user is going to search for that particular topic at a time. So for Google, at a particular time, Google receives 100 million searches queries per day. Okay, so it is infeasible to store that 100 million search queries per day or that 100 million of data at a particular time. So the same thing happens here also, that which is the most trending topics or which is the most important topic, then it can store that particular topics also. Means day by day, or when I am going to deliver my lectures regarding the unit 3, you will be able to clear, or you will be able to know about all these things, that how the Google receives that search queries and which kind of data it is going to archive and which kind of data is going to store in the summary all data, and how the standing queries, how the ad hoc queries are going to be performed on that particular kind of data. So whenever or day by day or through each and every lecture, you can learn about each and every things more clearly. Okay. Next is, what are the basic characteristics of data streams? It is most important characteristic is that it is a large volume of continuous data, which is possibly, you can say, infinite. The data which is coming is steady changing, and it requires a fast real time responses, because just like in the previous example, Google searches, the server doesn't know about which kind of queries are going to be performed by any kind of user. So here the changing data arrives regularly and it requires a very fast real-time responses. Okay. So this is one of the most important characteristics of data stream. Third one is, what is data? Data stream basically captures the data processing needs of today very efficiently. Okay. Next one is random access of data stream. In a data stream, if you are going to access the data randomly, then it is an expensive process and it requires a single scanning algorithm. Here the data streams are the continuous or voluminous amount of data. So it is infeasible, or it is impossible to store all the data streams which are coming from the different sources at a particular time. So what we do, we store only the summary of the data which is seen so far. The next characteristic is that maximum stream data are at a pretty low level of multidimensional creation. So it needs more level or more multidimensional treatment, because maximum stream data is a pretty low level. So what we have to do, we have to perform many algorithms, so we have to perform many multidimensional treatments to optimize that particular stream data at a high level. Now where we can apply the data streams. So first one is fraud perception, that I had explained, that if you want to identify that from where the IP network this fraud has performed. So with the use of measurement data stream, you can easily identify that particular fraud perception. Second one is real-time goods dealing. In real-time goods dealing, you also can you can also observe the data streams, from where the data stream is coming, from which source it is coming. So can also apply in the real-time good dealing process. Next one is in the consumer enterprises, we can easily see the uses of the applications of data stream. The third one is observing and describing on inside IT systems. The next one is sensor networks. Okay, so sensor networks basically it captures the information or it captures the data, okay, from over the different kinds of networks, so that it can that particular data stream can be used in the future or in the future actions. Next one is to identify the network traffic analysis, just like in the denial of service attack, some fraud or some third party overloaded that particular channel, traffic channel, through the spam messages. So to identify that particular traffic, network traffic, or to analyze that particular network traffic, we can also use a data stream. Next one is in the financial applications and in the transaction log analysis. Just like transactional data streams, if somehow any fraud has occurred during the transaction of amount from one bank to any other bank account, so due to that particular data stream, with the help of that particular data stream, you can easily analyze that where the actual misconception has occurred. Now, what are the different advantages of data streams? Basically, it is helpful in upgrading the sales in stock market. Okay. Next one is it is very much useful in recognizing the fallacy, means fault, or where the fault occurs or where the fraud perceptions has occurred. So data streams can easily be helpful in recognizing these kinds of facilities. Just like the next one is also it helps in minimizing the cost, and it also provides the details to react swiftly to that particular risk. Means somehow if any risk is going to be occurred, so it provides details to react swiftly to that particular kind of risk. Next is disadvantages of data stream. The most important or the most trendy topic is that the lack of security of data in the cloud is occurred. So this is one of the disadvantage of data stream, is in the cloud computing system there is somehow lack of security is occurred. Okay, next one is hold cloud donor subordination, and the last one is off-premises warehouse of details. It introduces the probability for disconnection also if there is any off-premises warehouses. So in online there is no problem of disconnection, but for off-premises warehouses there is a probability for disconnection, and this is one of the disadvantage of data stream. Now, what is stream computing? Basically, the high performance computer systems which can able to analyze the multiple data streams which are coming from different sources in the real time system. So the word stream in the stream computing is just how it simply means to pulling the streams of data and process that particular data. Again, it is streaming it back out as in the form of single flow. So stream computing basically uses the algorithms of software algorithms which analyzes the data in the real time, and also it streams into increasing that particular data streams speeds and accuracy when it will be able to deal with the data handling and analysis. Here we can see that the stream processing computational paradigm, which consists of assimilating the data readings from the collections of software or hardware sensors in the stream form, and then analyze the data and then produce the actionable results, possibly in the stream format as well. So here different hardware or software sensors are working in the stream from that particular streams. What is the process occurring here? The operators are reading the data or assimilating or collecting the data from that particular kind of hardware software sensors, and then that particular kind of operator converts that readings into the stream form, which is in the form of tuples, and then the user or the person here, which is seen in the diagram, it analyzes the data, and as particular requirement and as particular observation that he or she has acquired from that particular stream, then on the basis of that it produces the actionable results, possibly in the stream format as well. Okay. Now we will discuss about what is data stream model of what is the data stream architecture. So it is a real-time continuous and it is an ordered sequence of items which arrives from different sources and which is unfeasible to control over that particular kind of data streams, because the data stream is in continuous voluminous amount of data which is coming or which is arriving at a very high speed rate. So it is unfeasible to control over that particular rate. Okay. So it is not possible to control the order in which they are coming or in which the items are arrives, or also not feasible to locally store a stream in its entirely format in any memory devices. So it is unfeasible to store that particular voluminous amount of data in any memory devices. So here the data model architecture is given, in which from different types of data sources we are collecting the data, and after that here the stream processing is occurred. From stream messaging services, we have ingestion services. Here, two types of storage are long-term data storage and long-term result storage. Here we can store the results and here we can store the data. Okay. After that, after processing over the stream, we can generate reports on monitoring and other workflows. Here I want to discuss one more architecture, one more model in which we can see that multiple inputs are coming. Over here, there is a query processor. Here we performed standing queries. And here we have ad hoc queries. Here we have two kinds of storage. This is a summary all data storage and this is a archival storage. After that we have output apart from that. So in this particular model or architecture, we can see that here the inputs of various form from different types of resources or sources are coming. Here we can perform the query. Over that particular kind of data streams which are coming from different types of sources. There are two kinds of data storage here. First one is summary all data storage and the second one is archival storage. So as I said earlier that the voluminous amount of data is coming from different sources. So it is unfeasible to store all complete data in the entire form. So what we do here, two kinds of queries are mentioned here. First one is standing queries and the second one is ad hoc queries. So standing queries are those queries which are continuously performed over the continuous data which is arriving from different sources. Okay. So standing queries are those queries. Okay, and ad hoc queries are those queries which are performed over a particular kind of data, over a particular kind of situation of that particular kind of data. So standing queries is continuously performing or it is continuously working over all the data which is arriving. Okay. So what we have to do, we have two kinds of storage. So in archival storage, we have to store those kind of data which can be useful in our future actions, which can be useful in our future needs. Okay, not in current time. So that kind of particular data we can store in archival storage, and the data which is stored in that particular kind of storage cannot be processed any query in the current time. Okay. So in the summary all data, what we store, we store in this particular kind of storage. It is not possible to store all the data in an entire form in that any memory device. So what we do, we store only summary of data in that particular kind of storage. Okay. So what we do, suppose for example, different types of input, different kinds of data streams are coming from different kinds of sources. So what we do, suppose we have to store the average temperature. Okay, suppose weather temperature is in the form of data stream is arriving. So we have to perform the query over the large average over the average temperature. So what we do, as data streams are arriving, so what we do, we simply take the average of data streams which are arriving, and that average will be stored over that particular kind of storage. So if we have to see, or if we have to perform any kind of standing queries or any kind of ad hoc queries over that kind of particular data, so we can access that kind of data from this kind of a storage, that is summary or data storage. Now, what are the characteristics of data stream model? Basically, it data model or query processor, it allows both the order based or time based operations, and it has inability to store complete streams, which indicates that some approximate summary structure must be used. Just I had explained in the previous diagram, the one kind of storage is summary all data storage, and streaming query plans must not use any operators, so it also requires the entire input before any results are produced. Next characteristic is that any query which requires backtracking over a data stream, it is infeasible. So because why this happens? Because storage and performance, because due to the storage and performance constraints which are imposed by the data stream. So it is, if any query requires backtracking, then it is infeasible, because we are not going to store entire data. Okay, we are only storing the summary all data. Okay, in that kind of summary structure. Okay, so it is unfeasible. Applications which monitors streams in real time, they must react quickly to the unusual data values. Also, the scalability requirements also dictates that parallel and shared executions of many continuous queries may be possible. So, scalability requirements are here. Okay, but there is no streaming query plans can be produced, or there is also inability to store a complete streams. Okay, and also where the, if any query requires a backtracking over the data stream, then it is also infeasible. Here, the data can be stored into the three partitions, just like temporary working storage, summary storage, and static storage for the metadata. So, summary storage I had explained in data model and architecture. Temporary working storage I had also explained. So, we can store data into three kinds of partitions. First one is temporary working storage, summary storage, and static storage for metadata. Okay, so that's all for today. Thank you.